Okay, hey guys, how you going? My name is Matt Woods and I'm from the Perth Observatory. Thank you very much for attending this really incredible live stream. It just happens to be that due to where Perth and Lethbridge is in the world, we can do a live stream where we can start off with having Perry and Brady from Lethbridge Astronomy Society starting off doing some viewing, and then we can take over here in Perth and show you some amazing objects in the night sky, not only in the Northern Hemisphere but also in the Southern Hemisphere. So, and tonight not only do we have Perry and Brady from Lethbridge Astronomical Society, but we also have Roger Groom from Astrophotography Australia, and also a volunteer at Perth Observatory. And we have Galaxy Girl herself, Carol Redford from Astrotourism WA, and also Stargazers Club WA as well. So what I'll do is I'll let the other groups introduce themselves and a little bit about their organisations. So Perry and Brady, did you want to take over?
Sure. My name is Perry Sadie. I am on the executive of the Lethbridge Astronomy Society. Specifically, I am the secretary, but I also juggle a few other balls here at the Astronomy Society. I'm also involved in collaborations with the university, among a few other things.
My name is Brady Sherwood. I am the president of the Lethbridge Astronomy Society. And I've been the president for about 2 years now.
And how long have you been a member for?
I've been a member since about 2016.
2016, and I joined in 2019.
Awesome. Roger, let's hear it.
Yeah, sure, Matt. Thanks for having me along. As Matt mentioned, I'm a volunteer at the Perth Observatory, and also run a couple of side businesses around my day job. One is Astrophotography Australia, where I mostly these days teach astrophotography out of our private outside site that my wife and I own, and the Perth Observatory. And the other is Astrophotography Western Australia, a remote host. Telescopes for people around the world, and also have locals who actually lease out individual observatories for themselves to use under dark skies here as well. And tonight I'm actually out on site. I was planning on being at home, but I'm actually out at the observatory because I had a lot of work to do today, in amongst the thousands of flies and the 37-degree heat that is up here. That's Celsius for people around the world. So yeah, that's me, Matt.
Yeah, so it is a little hot here in West Australia. We're thinking we're going into autumn, and March is throwing a few summer days just to remind you that it's not too far away from summer as well.
I'm completely over it. And we do a lot of astronomy in the Wheatbelt and regional WA. We do a lot for Carol's Astrotourism found out in the region, and I'm over 40 degrees.
Yeah. Okay, Carol, the Venerable Carol, tell us about you and your organisation.
Hi there, thanks Matt. Hi everybody. It's really great actually. Perry at the Lethbridge Astronomy Society reached out about maybe 6 months ago. So this live stream tonight's been quite a number of months in the making, and it's really great, Perry. Like, I immediately thought, well, we have to link in with Perth Observatory, Matt and Roger, to make sure that all the technology works, and it looks like it will tonight, which is great. I'm Carol. I am sometimes known as Galaxy Girl in astronomy circles. I love what I do. I run Astrotourism WA, which is work that I'm doing with local governments in regional Western Australia to develop dark sky tourism, but also to reduce light pollution and protect our beautiful night sky. But in the intermission between hemispheres, later on tonight, I'll let you know a little bit about what we're doing. I'm an accidental stargazer, actually. I not an astronomer or scientist. I found myself co-owning and operating an observatory just north of Perth about 15 years ago, and so I had the great pleasure to stand with astronomers under our night sky to listen to the stories and the science of what's above us. So it's an amazing thing, and I'm really looking forward to seeing some unfamiliar objects in the Northern Hemisphere.
Awesome.
Matt.
And we've got a few people in the chat here. We have Hilty Goldtooth Reviews, Ganesh Merchants, Mike Davies, who is one of the Perth Observatory volunteers. Russell Stewart is from Canada. Hello. Barry Olson is from Lethbridge, Canada as well. We have Starbright Wonderland Photography as well here. So thanks guys for turning up. Okay, so what we shall do is we'll move over to the live stream side. So Perry and Brady, are you ready to take over and show us what amazing objects you're going to show in the Northern Hemisphere?
Absolutely, we're ready. So we have first a little quick presentation about the Lethbridge area and the Astronomy Society.
Awesome.
So as soon as you've switched over to that, we'll be ready to go.
Yeah, we're ready to go.
Perfect. All right. So the Lethbridge Astronomy Society, obviously located near the city of Lethbridge. So Lethbridge, Alberta, the province of Canada, Alberta, and then the city Lethbridge is pretty close to the American border, about an hour's drive north of that, which, if you know anything about political boundaries in Canada, the provinces are very large, kind of like in Australia as well. So saying you're from Alberta could be kind of, there's a lot of locations where that could be. So we're pretty close to the American border. And you can see our location right here, our main facilities.
You know, right in the river valley, so.
We are also located about an hour and a half's drive from the Rocky Mountains. Those are visible from different parts of the city off to the west. The most famous mountain in the Rockies nearby here, you can see Chief Mountain, and that is named after, basically the name comes from the indigenous Blackfoot culture that live in the area, and they have a lot of stories about the mountain itself. So we get to see that all the time. It's actually in the United States, but it's so high in the air that we can see it from Lethbridge.
Oh, nice.
Mm-hmm.
That's a foreign concept for someone in Australia where we're surrounded by water. That's a foreign concept to be able to see something which is in some other country from. Yeah, that's right.
Well, yeah, that makes sense. Absolutely. So we have our two main facilities here. This was a pre-existing building that we moved into several years ago. We just kind of call this like the main building or the main center. And then down here we have the Rick Ponemar Astronomical Lab, which we usually call the Dome because of the big dome on it. So this building was pre-existing, and this was specialty built for our purposes.
Awesome.
So we can see inside our main building here where we do public outreach as well as private events. So we can see our president Brady put together this wonderful Space Jeopardy game that we played that night. And then out here we have our main deck area where we do a lot of public events and everything like that.
Nice.
Here we have inside our dome, we have our main workhorse. This is a 14-inch Schmidt-Cassegrain reflector telescope. So for those of you who have no idea what that means, that's totally okay. The gist of it is that we have a telescope that is designed to kind of fold light paths up inside itself so that you can pack the field of view of a much longer telescope into a smaller package. So that's what we like about that thing. It's a lot more workable than an equivalent longer telescope.
Yeah, it uses a combination of mirrors and lenses to compact the image.
Mm-hmm. Out here, so we can see, as you've probably noticed, we are located in a valley, which is not ideal for astronomy, but it also kind of suits our purposes. It's near the city, but kind of away, so we have a big swath of the sky that is available to us for viewing. For people who are interested, this type of valley in Canada is called a coulee. And those were formed thousands of years ago from the melting of massive ice sheets that covered the land at the time. There are many coulees down in the United States as well, and then we have several that we are partially situated in the city of Lethbridge. So, brief introduction on our origins here. We might not cover every single point, but we do have the screen up, so you're welcome to review this at a later date. We started out as the Lethbridge Stargazers Club in 1984 with 6 amateur astronomers. They put that together, and they did a lot of public outreach, and the club grew for about 3 years before it became incorporated as an official nonprofit in the province of Alberta and renamed the Lethbridge Astronomy Society. And since then, public outreach has been one of our primary goals and things that we do. So you can see here, this is the construction of the dome that happened a bit later in 1992, and a few people that were involved in that.
Original members.
And because we are a nonprofit, the majority of everything that we have, things that we develop and acquire, our upgrades, equipment purchases, those are primarily through grants, nonprofit funding, and volunteer work and donations from our members. So you can see we've put a lot of work into improving our facilities and providing the best experience that we can here.
Awesome.
All right, and then just the last couple of things here. We also have been partnered with the University of Lethbridge, our local university, since 1990, where we provide labs and field trips for the students that are in the astronomy department, specifically at the university. And it's very involved. We do about 3 a year, but it's a lot of fun. We enjoy it a lot.
And they used to come down here, but now we've kind of been back and forth between the university and here.
Another major project that we've recently accomplished is the installation of the Lethbridge solar system model. So we did this partially during the pandemic when we weren't able to do a whole lot else. So this is basically a scale model of the solar system that we have installed throughout the city and actually extending out into the county, based off of a dome, a clock tower dome in the city of Lethbridge. It's about 5 meters in diameter, and we essentially use it to represent the sun, and then the planets and the orbits of the planets are scaled to that. And even at that scale, our installation of Neptune is about 18 kilometers distant from there.
Wow.
And that's out actually. So it's still a pretty large model. We unfortunately cannot boast that it's the largest in Canada, but it is definitely one of the largest models like this in Canada. And here's a picture of Jupiter.
Yep.
And you can see right there is the tower. So that would be roughly to scale of the size of the sun at Jupiter.
Boy, that's amazing, isn't it?
Yeah.
That definitely beats our solar system work.
Well, yeah, this was kind of a passion project of one of our members, and I joined right at the perfect time to be involved with it, and it was a lot of fun. And then finally, one of our latest acquisitions here is an inflatable planetarium that we can use even if it's cloudy or if it's raining. So we can actually kind of take this on the road to schools and libraries. And it's really cool inside. We have a nice projector that shows, we can show night sky videos, or we can run night sky software that has the right type of projection modes on them, and it's a lot of fun. Everyone seems to have great experiences with it. And you might be interested to know that we constructed the mirror projection with the advice of someone named Paul Borg. I'm not 100% sure how to pronounce that name, but he is from Melbourne, Australia.
Yeah, we actually have SciTech, which is the big STEM adventure world thing in the centre of Perth that actually has those, and we'll take them out to Astrofest here in Perth, where all the WA astronomy groups to come together and do a big astro festival as well, where we get telescopes on the lawn of Curtin University, and they actually bring those as well. So I've actually been in one of those, and they're pretty cool.
Mm-hmm. Yeah. They're a bit of a you have to train a lot of training to figure out how to put them away, but once you figure that out, they're a lot of fun.
Yeah, they certainly are. You could spend a number of hours in there.
So here's a low quality because just the lighting in there is usually very dark. I assume this gentleman here is not yawning out of fatigue, but crying out of awe of the majesty that he is looking at.
That's how I see it.
Yeah, 100%. So that's our introduction in a nutshell. So if you're ever in the Lethbridge area, we'd love to have you come down and check us out.
Awesome.
All right. So now we will be switching over. Unfortunately, it is cloudy in our location, but we are going to be switching over to our backup recordings that we made of the targets that we want to share. Just making sure that we have. There it is. Okay. I just need to maximize my screen. How does that look on your end?
Yeah, that looks good.
Perfect. So we anticipated cloudy skies. So we created backup recordings of the targets that we were going to show. So the image quality, it might be a little bit low because we're going over the internet here. Hopefully it's visible and it looks good from everybody who can see it. But yeah, so what we're looking at right now is an object called the Owl Nebula, which is located in the constellation Ursa Major, which is a constellation that in my understanding, you guys cannot see, or at least the Big Dipper is not visible.
Yeah, you have to go up further in Western Australia to be able to see that. We did see it when I was up at Exmouth for the solar eclipse back in 2023, but the first time I actually did see it was 2018 when I went up to America, and actually remembered to look up at the night sky this time because I did go to America in 2007 and got home and went, I didn't even get a chance to have a look at the night sky.
Right. Yeah, it's a very distinct constellation. I mean, of course, the Big Dipper itself is not a constellation. It's part of Ursa Major, but the Big Dipper is the most visible part, and it is very striking. It's very hard not to see it in our night sky.
So you can see we captured a little bit of an airplane coming through this. So.
Oh yeah. See that. Yeah.
But we're taking what we're doing in this. We're taking individual frames. So I believe we're doing 60-second image shots each, and then stacking them on top of each other. So right now I think we've only got seven stacked images, and then so as we get more and more, our images get better and better, and we can adjust our histogram here, right here. Once we get a little more detail, and the colors will start showing a little bit better.
So I do have Stellarium here, so what I'll do is I'll change over to Stellarium, and I'll be actually able to show people where it is. So I've got Stellarium as if they're at Lethbridge, and so you're looking in the northwest, right at this time. And then we can zoom in, so it's almost smack bang in the middle right there. So, and there it is.
You got the surfboard galaxy next to it as well. Okay, so I'll just switch back to the live stream.
There you go. And
So what we wanted to do here is specifically show kind of our capture process. You can see our software here. This is called SharkCap Pro. I am not well versed with it, but Brady has had quite a bit of experience with it, so he kind of knows how to troubleshoot a few of these things. And yes, so the Owl Nebula, for people who are unaware, this is a planetary nebula, and what that is essentially the remains of a dead star. Stars have life cycles. They're born, they live, they grow old, and they die. And when they die, usually one of three basic things happens to them. One of those things being a planetary nebula. And so essentially the outer layers of the star will kind of just blow up like a balloon and then fly away. That's essentially what's happening here. So we can see a lot of the gases that used to be part of this star. And this is a pretty new nebula. It's only around 1,000 years old, which is actually very young for things in the night sky. And you can see there's still a little bit of glow as these outer layers are down. And you can see it kind of fading green to red, and that's showing you essentially different types of gases that were present in the star. They can be kind of represent different gases depending on exactly what's going on with them. Red generally means hydrogen. So you can see a little bit of red around the outside of this thing. And the reason it's called the Owl Nebula is kind of at the very center. It sort of looks like two ghostly eyes boring into us from across the universe. It's a little disconcerting, but I'm sure it is not aware of us, actually. And at the very center, you can see a light, and that is a newly forming white dwarf, which is the core of that dead star, that is squeezed down to kind of about the size of the Earth. And these white dwarfs, they are so dense, they're kind of crazy. They have surface gravities that are like hundreds of thousands of times stronger than the Earth. It's not a place that I recommend visiting on like any sort of a space tour. Maybe come up to see the pretty gas clouds around it, but don't get too close to the actual center.
Yeah. I don't know if you will go to the next one.
I remember doing a lot of visual observing of planetary nebula back in the early days of my amateur astronomy life at local astronomy club, which I still remember as Astronomical Society WA. And it's a fascinating object. Great to see what you can see in planetary nebula through a telescope visually, and just so many of them to be able to photograph.
Mm-hmm. This is one of our favorites. It's a very interesting object. So if anybody has any questions for us, and it can be about the Astronomy Society or about the object we're looking at right now. We'll be staring at it for a few more minutes.
Awesome. How far away is it from us?
If you go to the beginning of the video,
the object is, I have this written down here, about 2,000 light years away.
2030.
Ooh.
So for those of you who aren't fully aware, a light year is the distance that light travels in 1 year, which is roughly 10 trillion kilometers. So 2,000 of those. It's a very long road trip. But as far as the universe is concerned, this is a relatively nearby object.
Yep. Yeah, it is.
Yeah.
Well, it's also interesting how the ratio of 2,000 light years away, but it's only 8,000 years old. So, I don't know, that seems like a fairly strong ratio that we haven't, it's only been around for such a short time, and so much of that time has been just the light travelling towards us.
Yeah. Yeah, so it's...
Yeah, it's near enough that a big chunk of its history is still, it's the light travel time is a big chunk of the history of its development. So it probably looks very different now where it is.
It reminds me a lot of a planetary nebula which we've photographed here quite a bit, which we call the spare tyre nebula. I've forgotten what its NDC or IC is, but it's called spare tyre. And it looks very similar to that in the realm of planetary nebulas.
Harry, is this object available to you for your whole season that you run to show people?
I am not entirely sure about that. We do the Big Dipper. It's Ursa Major, but not all of Ursa Major is above the horizon. Well, yeah, it's not above the horizon all the time. And the Big Dipper, it will oscillate between being very high and very low. And I believe it's very high in the winter, and then it is very low in the horizon in the summer. So there is probably a season for this object where it's most visible, and then there's a part of the year where, at least in our location, we wouldn't be trying to find it because it's probably behind the coulee or something like that.
Too low. Yes, you probably get it at the beginning and at the end of the season, perhaps, to show people.
Yeah.
I feel for the majority of the time you'd be able to see it.
Yeah, for most of the year, this thing would be visible, yeah. All right, we're just about ready to switch over to our next object, but if anybody has any final questions, we'd be happy to answer.
Yeah, I think we can go to the next one, yeah.
Perfect. Okay, the next object here is going to be an object that we call Bode's Galaxy. This is also known as Messier 81. And this galaxy is also located in Ursa Major, and it is actually kind of a duo. It's near to another galaxy called M82, or the Cigar Galaxy. This is a very beautiful galaxy, and you can see here, this is the first frame that we get of it. The first frame tends to be a little bit weird with the colors, right? And then as more images come in, we do a little bit of fiddling to try to get the galaxy exactly where we want it.
But then our 14 picks up pretty much our center. So it's quite the object.
This object is pretty near and pretty large. It's called a grand spiral galaxy, or a grand design spiral galaxy, which means it's one of the archetypes for this type of object. It's like the standard by which we compare other types of galaxies.
What kind of exposure time are you doing there to get a fantastic single frame like that?
60 seconds.
Yeah, we often will do 60 seconds. Sometimes we do 2 minutes. We can do longer, but we are just near enough to the city of Lethbridge.
Our gain is quite high on this one, so our light sensitivity is up almost 350. We were messing around with it, just seeing how best to set, how it would stack better.
It looks
Maybe we'll jump
fantastic,
ahead
but
just a little bit. Jump ahead to about there. There we go. So now we have the colors a little bit better. A very beautiful galaxy. Again, for people who are not fully aware, galaxies are big, essentially massive countries or continents of stars. So, you can imagine all of the towns and cities in Canada or in Australia, all combined, and that say the galaxy itself, or Australia or Canada. And so there's just there are hundreds of billions of stars. There can also be very tiny galaxies as well, dwarf galaxies. And when they have these spiral arms, we're just moving around the panel there so we can see things. When they have spiral arms, they're called spiral galaxies, and they're often some of the prettiest as well.
Just trying to get the full view of this.
So M81 is located about 12 million light years away, which again, that's much further than the Owl Nebula, but the Owl Nebula is in our galaxy. This is a separate galaxy. So when it comes to these distance scales, galaxies are usually much further away than that from us. So 12 million light years is pretty good. This is relatively nearby. This isn't next door, but it's like down the street. You could yell and then you could hear people yelling back.
That certainly is pretty close for a showpiece galaxy like that. I mean, most of the ones we enjoy photographing in the Southern Hemisphere here sort of around more that 50 million light year kind of range. So yeah, that is pretty close in the scheme of things.
Yeah, absolutely. And we also have the Virgo cluster too, which is probably visible. I imagine that's visible from Australia, right?
Yeah, we do have that.
Yeah, those have some very iconic galaxies. They are a little bit further away, and then that cluster has a lot of interacting galaxies. And when large galaxies smash into each other, they tend to lose their spiral structure, and they become what are called elliptical galaxies. And those can be like ball or cigar or pancake shaped, but they don't usually have structure like we can see with this galaxy. We can see arms, we can see dust lanes here, and this galaxy also has a lot of what we call star forming regions. We have these little purple balls that you can see all around it. Those are where new stars are forming. So they're like stellar clusters where baby stars are born. Another thing that's interesting about this galaxy is because it's so big and bright and nearby, we actually, a lot of the objects that we look at down in this building with our Schmidt-Cassegrain telescope, we need a camera to image them. They're so faint, so we collect light over time, like what we're doing here. And we certainly need to do that to get all of this structure that's in this galaxy. But this galaxy is bright enough and big enough in the sky that we can see it with our regular telescopes that just have eyepieces on them. So it's one of the galaxies that I like to show people when we do our public events, once we've seen some of the more interesting objects in the sky. And if people are still interested, I'll try to find this galaxy and its neighbor.
Yeah, so the neighbor is the cigar galaxy, but it won't fit in this frame, so we were going to image it separately, but we just never got another clear night to image it.
But those galaxies are both visible in the same view at a slightly less magnified eyepiece. You can see them both at the same time.
It is just so stunning, isn't it?
Yeah.
Yeah, and
lanes
as
and
people who, we all enjoy showing people the night sky through our different observatories and other things that we do. So I like how you said sort of that relates to that situation where you have people sort of hanging around towards the end of the night or something, which have sort of seen the showpiece stuff, seen the normal stuff, and you get to do a little bit more fun stuff where you have a bit more time there kind of thing and show a bit more interesting objects, I suppose.
Yeah.
We all enjoy doing that.
Yeah, absolutely. We start going to personal favorites or just like, well, let's see how dark it is tonight. How far can we push?
How far can the conditions let me?
We always used to have a mystery object. Yes, I was just saying at the observatory I used to run up in Gingin, we always used to have a mystery object. So at the end of the night, through the night, of course, you show all of the really popular objects, like all the planets that are up and the moon and all of that. But afterwards, we'd let the astronomers go wild and they could have a look at anything they wanted to. So we'd send people back out to the observatory floor if they were still keen to do some observing. And usually it was those faint and fuzzies that they were really keen to get the telescopes on. Yeah, really fun. It was a great way actually for those who are really dead keen on seeing some different objects in a dark sky location. That was a great opportunity for them to see some new things that they hadn't seen before. Looks like a great object.
Jealous. It is, yeah. We definitely do like to bring out like the galaxies at the very end of off-site visits. We were showing the triplet, the Leo triplet, the other last Friday, and also Centaurus A galaxy as well.
Yeah, we like the Leo triplet. Another interesting thing about this galaxy, the Bode's galaxy, is that it has a central black hole of about 70 million solar masses. So a solar mass is the mass of one sun, one of our suns, which, as you can imagine, is fairly massive. It is the biggest thing in our solar system. So imagine something that is 70 million times more massive than that, and that is this galaxy's black hole. We now know that most galaxies have supermassive black holes at their centers. We don't 100% know how they get started. We have some ideas, but we are able to figure out the sizes of many of them. We know that our galaxy's central black hole has a mass of about 4 million solar masses, which is very big, right? It's the biggest thing in our neighborhood, but clearly it's not the biggest kid in the universe, as this one is about whatever 70 divided by 4 is, that many times larger.
So we have had a question saying, how come no jets?
How come no jets?
Yeah, I'm guessing from the black hole. I'm guessing it probably isn't particularly feeding at the moment, is it?
Yes, well, so these two galaxies, Bode's galaxy and its neighbor, the Cigar galaxy, they are both active galaxies. So they both have what are called active galactic nuclei. Those are essentially supermassive black holes that are active in some way, right?
Yeah.
But they can be active in there's like a big scale of activity. And the kind of a weird thing about active galactic nuclei, their category is partially to do with what the black hole is doing, but then it's partially to do with the angle that we are viewing the galaxy at. So there's a lot of wiggle room in exactly what each of these types mean. This galaxy, I believe, is a Seyfert galaxy. It does have an active nucleus, and it apparently does have a jet. But that does not mean that it's a very large jet, or that the jet is particularly visible in visible light.
That's where you need radio telescopes.
Yes, that's often the case. That might not be quite the deal with this galaxy. It might be that its relativistic jet is very small compared to the rest of the galaxy that we can see. Whereas some other galaxies you can see in the right type of light, such as radio light, you can see some of these jets shooting out many, many times the diameter of the galaxy, right? But yeah, it does not look like this jet is visible in the type of images we're able to get.
Yeah. We did actually have Dr. Michelle Bennett take a photo of Centaurus A galaxy, and that's got a particularly strong jet, and she managed to actually get dust in that jet. So you can just slightly make out some of the material in the jets, which is just astounding to me from that. That's how good the image was that she caught. One thing...
The core of the galaxy is pretty bright anyway.
Yeah.
Yeah.
You might have to use quite a bit of Hubble telescope cropping to get that jet.
Yeah. So this is where Bode's galaxy is, or M81. So it's just off the head of Ursa Major there, and we can zoom in. And you've got those other galaxies there that look so cool as well. We do have a couple more questions. Says, is there a death galaxy where everything is blown away and only red dwarfs are left?
Okay. Let's see what I know about that type of a question. I did some research on galaxy evolution a couple of years ago for a presentation. And we do know that galaxies evolve over time. We do know that's a process that will continue as the universe ages, and so a lot of that's unknown because we're still kind of at the beginning of that process. But we have seen distant galaxies that there's a concept called galaxy death, where not that the stars all burn out, but that the galaxy loses its ability to form new stars. That tends to happen over time. All galaxies kind of evolve towards being unable to form new stars over time. But the time that would be necessary for all of the larger stars to burn out and only have red dwarfs, we do know like the lifespan of these of different categories of stars, and we know that stars like our sun take about 10 to 15 billion years, which is about the age of the universe, to actually die. So we're expecting some of those stars to be dead for sure, but anything less massive is going to live much longer, like K-type stars, which can live many dozens of billions of years.
Yeah.
And so it would take much longer than the age of the universe for us to reach a point where a galaxy only has red dwarfs. Be quite an interesting revelation, and that would be quite an interesting revelation, and would challenge what we understand about the history of the universe.
Yeah, because the very first black red dwarfs. Yeah, the very first red dwarfs, there hasn't been enough time for them to die as well. So some of these really far galaxies that James Webb is being able to show, they're probably dead galaxies which just have red dwarfs. Alright, thanks John Mitchin for those questions. Alright, so Perry, do you guys want to move on to your next object? That's in my...
Absolutely, do that.
That's Messier 101, the Pinwheel Galaxy.
Well, we can do that one. We also have the Whirlpool Galaxy, which I believe is what I actually meant when I said Galaxy, and I mentioned. I was thinking of the Whirlpool Galaxy when I said we definitely want to try to do that one. Very beautiful galaxy.
Yes.
One was 130 billion light years.
All right, let's see if we can jump ahead to get this galaxy. So this is probably our first frame. Now this one is a very iconic one. It's very likely that many of have seen this galaxy, a picture of it before at some point, because it's very iconic. You see this very beautiful spiral galaxy, and then there's this other galaxy right next to it, and it almost kind of looks like a snail. A snail shell with a snail coming out or something like that. So this galaxy is, again, it's called the Whirlpool Galaxy. Astronomers like to have fun nicknames for a lot of different objects, and they're often quite literal. It's just like, what does this look like to me? It looks like a whirlpool, so let's name it that. So this galaxy is...
And when you're in the Southern Hemisphere, it's called the Southern Whirlpool Galaxy, which is a completely different object. Yeah. So it's another grand design galaxy as well.
Right. And I think we also have either the Southern Owl or the Little Owl Nebula or something like that. So, sometimes these names get recycled a little bit.
And I'll just move to
Stellarium to show everyone where this is. So again, we're at the tail of Ursa Major. So again, we can't see this with our own eyes here in Perth. And if we scroll in, and for anyone interested, this software is called Stellarium, and it is completely free. You just put in Google search for Stellarium, and you can download it for your desktop. And there's also a version for Apple and Android phones as well. Okay, so
we've got back to you guys.
So this galaxy, that's our first target outside of Ursa Major. But the constellation that it's located is kind of interesting because it's as you were probably able to see in Stellarium there, it's like one or two or three stars. But it represents a pair of dogs that is being walked by Boetes or something like that. And so I always find it interesting where some constellations actually do look like what they're named after, like the constellation Orion kind of looks like a hunter. But I don't think Canis Venatici looks like a pack of dogs. But apparently some Greek people believe that it did. So, I mean, who am I to judge? Oh, somebody triggered the infamous Windows 10 if you scroll over the wrong entire station. So this galaxy, as Brady is 31 million light years away. And what's interesting here also is that you can see that it's a spiral galaxy. This is also the first galaxy classified as a spiral galaxy. So the concept of spiral galaxies were being developed at the time, and then this galaxy was a recent discovery, and then it was classified as a spiral. We decided that one is a spiral, so it was the very first galaxy to be given that classification.
And it's also interesting just to think of like these galaxies are colliding, and we're seeing it from 31 million light years away. Well, by now, if these two galaxies could totally be merged at this point.
Yeah.
There's definitely a bit. They'd be a little bit more. They'd
Closer.
move a little bit more. They'd be in relation to each other.
Yeah, when we're looking through a telescope, we're actually looking back in history.
Yeah.
And the difference between grand designs and galaxies and our galaxy is that we have that bar in the middle. Our galaxy is a spiral galaxy, but it's a barred spiral galaxy.
Yes, we have discovered a bar in our galaxy, which is kind of amazing when you think about it, because looking at our galaxy is very hard to do. It's almost, I use the analogy of like trying to study your face when only using your eyes, being unable to look into a mirror. And so you're trying to figure out things where in a location where you live. It's very hard to see. You can't see the other side of the galaxy. It's very difficult. So the fact that we know that we have a bar is kind of a testament to the dedication of astronomers to try to figure these things out.
It is truly amazing, isn't it?
Another interesting thing about the Whirlpool Galaxy is that it is the location of the first possible detection of, not aliens, unfortunately, but of an extragalactic planet, a planet from outside of our galaxy.
Wow.
We are aware of many planets that are not in orbit around our sun. Those are called exoplanets. But it's very difficult to try to make those types of observations in another galaxy. So how were we able to do this? It was essentially, my understanding is that something passed in front of either a neutron star or a black hole. Something with a lot of gravity that had hot gas orbiting around it that was emitting X-rays very brightly that we were able to see from the Earth. And then at some point that X-ray source was cut off and then started again. And so that might suggest the existence of a planet in orbit around that dead star. It could also be like a cloud of gas go by. So we would need to see it again and figure out how often it's happening before we could make any sort of, definite conclusion that it's most likely a planet. But if it is true that it would be the first discovered planet from outside of our galaxy.
That's just astounding that we can use these very special types of occultations to possibly have actually found the first exogalactic exoplanet as well.
Mm-hmm.
And it is quite large, the galaxy itself. It's 170,000 light years across. So our galaxy is only about 110,000 light years across.
Yeah, so it is very likely much or decently larger than our galaxy. It's the weird thing is when you do try to find like estimates for the diameter of our galaxy, they kind of range between about 80,000 light years to around 120,000 light years. Usually we settle on about 100,000 light years. Yeah. But again, it's kind of hard to see because we can't see all of the stars in our galaxy because there are so many other stars that are in front of them. So a lot of times we have to make estimates based on what we can see and how we think these stars are orbiting, because that lets us know how the gravity is working, and that lets us determine how much mass is in the Milky Way and in other galaxies. Of course, that gets a little confused when we try to factor in dark matter, so that's a whole other can of worms to try to solve.
Yeah. What about the LMC?
So, yeah, the floor is open for any questions anyone has.
So John mentions asking, what about the Large Magellanic Cloud and the Small Magellanic Cloud? So these are two dwarf galaxies that are in the Southern Hemisphere. So the large is about 160,000 light years away from us, and the small is about 250,000 light years away from us. So they do orbit our galaxy, and they are actually connected by a magnetic bridge between each other. So they are swapping gas and dust. The Large Magellanic Cloud, I think it's about nearly 10,000, it's about 32,000 light years across. So it is definitely bigger of the two. It was already an irregular galaxy where they think the Small Magellanic Cloud, that was actually a small spiral galaxy, and as they've collided, that's when they've distorted that one as well. So the small one's about 19,000 light years across, so they are quite small, and they exist below the disk of the galaxy. So in about 1 to 2 billion years, they will be included in the Milky Way, as John says. We usually like to say assimilated, like the Borg. Resistance is futile. So.
I like to say that bigger galaxies like to eat smaller galaxies.
Yes, they can. Actually, John brings up a very interesting thing. The first supernova we saw with the naked eye was in the Large Magellanic Cloud, and it actually happened on my first birthday. Yeah. 1 year. If it happened 1 year before, I could have said that a supernova announced my birth. So, yeah.
So that was in 1987, right?
Yeah. So now people know exactly
my birth.
Yeah.
That was my birthday supernova.
Yep. And it lasted for a few weeks as well. One of our friends, Roger and my friend Steve, he was actually working on the night and had a look at that, saw the star and goes, oh, there's a new star in the Large Magellanic Cloud. And Dennis Haywood, who is working with, goes, don't be stupid. You can't see a star in the Large Magellanic Cloud. He goes, no, there is. And he came out and he goes, oh, that's a supernova. First supernovas for 400 years. So, yeah.
Yeah, that's crazy. And so that one's about, 120 or 180,000 light years away. So that's how long ago that star actually blew up.
Yeah. Yep. And you're starting to, because Hubble came out only a few years afterwards, they've been able to take regular photos of that star, and you can actually see the shell of material expanding from the star, from the actual eruption as well.
That's cool. For anyone in Australia wondering, we cannot see the Large and Small Magellanic Cloud from Lethbridge. We wish we could.
Yes. Yes, I went on a cruise with Fraser Kane from Universe Today, and he's wanting to come down to the Australia to see the 47 Tucana, Omega Centauri, the Large Magellanic Clouds, and he actually got to do it a couple of, I think 2019 he got to do it, so yeah.
That was Fraser Kane, eh?
Yeah, it was amazing seeing him in the real person. So.
Oh, and you might have just accidentally heard the very first Canadian A of the
Hey,
night.
yes.
I think I said that without thinking. It's not as common as you think it might be in Canada, but people do say it sometimes.
I don't know if we've had a boot yet, so.
Yeah, I don't say that. There's a couple of words we use. We often will say like progress instead of progress. Maybe you guys say progress too. In America, they don't.
Yeah.
They like to make fun of us for that.
Sometimes. I've been known to switch pronunciations based off Australian and also the US, so I said vase today where we should stars. So.
Ah, yes.
Alright, guys. I think we've reached the time for Carol. Now you guys get to sit back and get to enjoy looking at images of the Southern Hemisphere.
Awesome. We are looking forward to it, and thank you for all your questions. We hope you enjoyed our northern targets.
Awesome. Okay, so alright, Carol, let's have a look here.
Absolutely, Perry. Thanks so much for that. It's just magnificent to be able to see different objects through, your lenses on where you are in Lethbridge. It's just, really fascinating objects. So thank you so much for joining us and sharing the Northern Hemisphere sky with us. I'll show you some of our southern sky now in the Southern Hemisphere. As I said earlier, I am an accidental stargazer and found myself at this observatory just north of Perth. At the time we called it Gingin Observatory, and I learnt two really valuable things there. One was that people love to come to an observatory and enjoy the night sky. They always left in awe. It was such a beautiful experience for people of all ages, all backgrounds. They just loved looking at the night sky with us. But the other thing I learnt when I was there, or I could see was happening, was the light pollution from Perth was getting closer and closer to the observatory every year. We have a lot of development up in our northern area of Perth, and that you could see that light, as it was creeping closer to the observatory. And it was those two things that set me on, this pathway that I'm on at the moment. And, I started learning a lot about the light pollution and how it's a global problem. But at the same time, I could see that Western Australia is really special because Perth being so isolated, Perth's the most isolated capital city on a continent in the world, means that most of our light pollution is just in that one place, because about 80% of West Australians live in Perth. And it means we've got this beautiful, beautiful dark, acres and acres and acres of dark sky. And that is worthy of protection. So about 7 years ago, I embarked on a project called Astrotourism Towns. And I now work with all these amazing local governments and we're doing two things. We're developing our destinations as dark sky tourism destinations. So it's, fantastic. We've mapped out in excess of 50 places so far, with usually the night sky quality meter readings in excess of 21.3. So they're really fantastic dark skies. And for people with telescopes or cameras, there's some fantastic places to go visit. Really brilliant working with local government to develop dark sky tourism for Western Australia. But at the same time, we're working together to make sure that we're protecting that asset, making sure we're not shining light up into our dark sky and ruining the view of the stars. And I've been working alongside our WA Local Government Association, and also that's Ian on the left there, and Tristan in the middle. He's from our Department of Biodiversity, Conservation and Attractions. Tristan works on up in our northwest of Western Australia, we have flatback turtles. So he's very interested in making sure that foreshore lighting is correct so that the turtle hatchlings, when they hatch, they don't get attracted to bright light on the land, they get attracted to the natural light reflecting off the ocean. So we've been working alongside each other, and last year, about a year ago, we had a big push and got a lot of local government support to have the interest to have a dark sky approved street light. Because at the moment our street lights that we have in Western Australia aren't suitable to protect our nighttime environment. And it was a brilliant breakthrough. We have our predominant power company called Western Power, and they have inserted a section in their lighting asset management strategy. I can't believe I'm excited about section in the lighting asset management strategy. It's like I never thought I would say that, but it's really important because it recognises that smart LED street lights and dark sky initiatives will influence street light design in the future. And so at the moment they are actively going out to try and seek a dark sky approved street light so that we can protect the beautiful view of our stars in the sky, and not only that, but wildlife and human health, and that, you know, the cultural heritage of our night sky as well. So it's been a really exciting year, and sort of more to come in the future. And you know, the big thing we're going to try and do here in Western Australia is create some international dark sky communities. So we're lucky. I mean, there's over 250 international dark sky places worldwide, and you can sort of see there's a lot in America and a few in Canada and also in Europe, but hardly any in the Southern Hemisphere. We have 6 in Australia now, but none in Western Australia. But I've got 2 of the communities that I've been working with are just starting their first steps towards international accreditation, with the hope that we will have this street light, which is, you know, it'll be one of the criteria that we have to make in order to prove ourselves and become internationally accredited. So that's really, really exciting future. And we're doing some really great things. We've been making these local observing places. So these are great. Local government's so cool. They've put in these concrete pads and with some seating and also this signage, like you know, to help novice stargazers learn a little about like turning out your lights, watching for satellites, getting your nighttime vision. All of those little tips that make a really great fun stargazing experience. And we've been making these giant planispheres, which is really fun. For those of you who don't know, that wheel in the centre there that I'm holding to, that turns. So it's an interactive sign, and a planisphere is you turn that disc and match the date you're stargazing to the time of night that you're stargazing, and you'll have a picture of what's actually up in the night sky to go and see that evening. And it's a great self-interpretive way to learn a little bit more about the night sky and what's up there. So that's been really, really fun. And the places, I thought I'd share some of the photographs. These are all mine. I'm very beginner at astrophotography, and a really great friend and colleague, Michael Goh. He is an astrophotographer here in Western Australia, just like Roger Broom is. Michael helps me process the images so that it makes it, they make them really great. This is an amazing sculpture up in the north in our Pilbara region near a town called Paraburdoo. It's called Resilience. It represents one of the large mining truck tyres, and that was magnificent under the Milky Way. You can actually see, though, in the distance, you can see light pollution from our mine sites that are up in the Pilbara. We have a lot of mining up there. A little bit further south, at Gascoyne Junction. That's right. So the Shire of Gascoyne is on the Astrotourism Towns map. And this was really fun. They've got a Cessna aircraft in the centre of the Gascoyne Junction, which is their main town. And I thought, my goodness, that's going to be fun to try and take a photo of. So we did that, and it's even in the town, it's quite small. There's hardly any street lights, so there was no light pollution.
It is an absolute fantastic town. I got to go there every year at least once, and
it's a great.
Yeah, and even if you go there, like there's the Kennedy Ranges nearby, and they also have this chef there, and he just makes the most amazing food. The lamb shanks are amazing. So it's 2 hours east of Carnarvon, so people would normally just miss it because they'd go from Carnarvon all the way up to Exmouth. But it's worth just heading inland for a period of time and just spending some time in the Kennedy Ranges because it's so picturesque. And I think the person that won the Astrotourism WA award in last year's Astrophotography exhibition for Astrofest did take their photo in the Kennedy Ranges near Gascoyne Junction.
That's right, they did. Yeah, it is an amazing community, like really tiny, but just punching above its weight. And visitors really love it out there, and you get these amazing night skies. Definitely a place worth visiting. And just recently I've been working out in the goldfields. So the Shire of Menzies is wanting to develop dark sky tourism. The goldfields has a lot of historical tourism, old towns, the gold mining history, all of that, but they're wanting to diversify and have something different in their mix. So this is a place called Mount Owen, and it's about, it's only a few minutes drive out of the town of Menzies, and it's lovely. It's going to make a beautiful observing site. That area gets really strong easterly winds, and this Mount Owen, we've chosen a site just on the other side so that the small hill there will protect anyone going out with telescopes from the wind, from the strong wind. So that's going to be fun. And I'm heading out there in early May. We're going to have a community stargazing night and at the new observing site, which will be really, really fun.
And you can actually see the large and small imaginary
you
clouds
can.
on the left there. Yeah,
That's right, yes. So this is the large, or is that the small?
That's the large there, and then up the top.
The large Magellanic Cloud, that's right. That's the
That's
small.
the view I want to see one day.
Yeah.
That's right. And this is, of course, that band of the Milky Way. In one of my next slides, I'll show you our most famous Aboriginal astronomy constellation. But yeah, so this is going to be fantastic, and we'll have an event out there early May. This is at Ninganoo, another really great town. It's a historical barn there, just out of town, and you can camp here overnight. Really fun. I think I just used my torch to illuminate the building a little bit so that I could get a bit of light on that beautiful red colour of the brick there. But again, beautiful night sky. At Minganoo, there's a space centre there.
Lost Carol.
What was that?
Where have you gone, Carol?
I'm here.
We can hear you.
Can you hear me?
Yep, I can hear you.
Oh, you can? Oh, good. I must have dropped out at Roger's end.
Have we got Carol coming back, Matt?
There is a beautiful, fantastic space science facility just north of Minganoo. So there's a lot of space industry and space science happening in Western Australia as well. And Narrabeen, so our beautiful wheat belt, there are so many beautiful places. This is a place called Avoca Farm. It's got historical buildings. It's actually a really great place for astrophotographers because there's all this old machinery, equipment and tractors and buildings, and you can just have so many different scenes just all in that one location. So really great fun. And Narrabeen is one of the communities who's just starting to try for their accreditation for a dark sky community, along with Upper Gascoyne Junction and Narrabeen. They'll be able to that will start that process, which is really great. And this one I wanted to show you because this is taken down in our southern wheat belt at Lake Grace. So Lake Grace has got amazing salt lakes everywhere, and you can be out there and, you know, it's just, you've got the Milky Way literally horizon to horizon. And in this image, you can see the Magellanic Clouds again. They're on the southwest side of the sky this time. This is the large Magellanic Cloud there, and the small Magellanic Cloud there. So, yep, what you're looking at are two satellite galaxies to our own Milky Way galaxy. But probably the best known Aboriginal astronomy constellation is the Emu in the sky. And there's some amazing stories, and the Emu, it is very connected to what's happening, you know, on the land for sourcing food. So when emu eggs are a really nutritious and amazing source of food for Aboriginal communities. And so when the emu is like this and rising, it's showing that it's sitting on the nest and it's time to go out and grab some emu eggs. So you'll see here, this is our Southern Cross. You see those stars there. And these are the two pointers that point to the Southern Cross. So you always look for those two bright stars. This is Alpha Centauri. So Alpha Centauri is, well, it's actually a triple star system. And one of those stars in that system there is called Proxima Centauri. And that's our next nearest star to Earth after our Sun. So you're looking at the closest stars there after our Sun. But these pointers, they point up to the Southern Cross here. So if you can get down to the Southern Hemisphere and get out under the dark sky, always look for the Southern Cross, and just underneath there's the Coal Sack Nebula. But you can kind of make out the shape of an emu head, sort of its beak coming off this way, and then the neck of the emu comes down here. It's the dark parts of the sky. So this constellation is not made up of stars, it's made up of dark parts. So there's the head, and the neck kind of comes here, and then there's a big body. If you can see that darkness through the Milky Way band there, that's the body of the emu. And then there are some legs that dangle down underneath. So it's quite amazing. I hope you can see that, the head, the emu there.
And it's one of those things that you can really see it in with the naked eye when you go out to dark sky locations. It's really prominent there. Even at the observatory, you can see it. It's getting a little harder with the LED lights, but it's still prominent, and that's 45 minutes out of Perth.
That's right. And I probably have run out of time, have I, Matt?
Do you have a... Yeah, that's... Oh, yeah, we can get a little longer.
Yeah, I was going to just share with everybody the total solar eclipses that are coming up. You know, it's so strange. As we are going streaming tonight, there is a partial solar eclipse that's just finishing up, actually. It was visible in eastern Canada, so not where Perry and the team from Lethbridge are, unfortunately. But it's just finishing up at the moment. And solar eclipses are amazing. You know, if you're on viewing, let us know if you've seen one and where you were when you saw it. Because it's terrific for Australia, because we are a total solar eclipse hotspot over this sort of next 10 to 15 years. We had one back in 2023, which just grazed the Exmouth Peninsula there, and it was fantastic. There were people from all over the world who came, all sorts of astronomy clubs from everywhere, and Matt and I were there. Matt live streamed the total solar eclipse for time and date, was it, Matt?
Yep. Over 100 million people.
Yep. Amazing. It was a really fun time. But we have 4 more coming up across Australia and New Zealand regions. So this one, July 2028, is going to start up in our beautiful Kimberley area, right to the northeast of Western Australia, and traverse right across to Sydney and then into New Zealand. The next one coming up after that is in 2030. And this one, Western Australia misses out, but it's a great, celebration for South Australia and Queensland.
I suppose we have to give them something.
I know. And then we have to wait a little bit. We have to wait about 7 years. But in 2037, this one goes smack bang right over the centre of Australia. It's going to be quite an incredible time. And it hits New Zealand as well. And then we have one more in 2038, again, right across WA, South Australia. So these are amazing events. When I first started my project 7 years ago, I knew that these were going to be happening, and I knew it was an important time to promote our dark sky tourism in Western Australia, and that was my mission. I decided I would use those eclipses to make sure we publicise Western Australia to the world and make it the stargazing capital of the world. Yeah. So really, it's going to be an amazing time. And I was talking with Perry earlier, and Perry was saying the next eclipse in Canada, a total solar eclipse in Canada, visible from Canada, is not until 2044. Is that right, Perry?
That's going to be the next one that happens directly overhead in Lethbridge in 2044. There is a partial eclipse happening in eastern Canada right now, but it's like over an area of Canada where almost nobody lives. There will be some people. There will be some Indigenous people up north. There's a city up there that will probably get to see some of that. And then I think there might be some other partial or totals that are kind of nearby, but that's like our next big one is in 2044.
No, so we've got an exciting time ahead.
For the 2028 one, it is probably actually better to be in the north of Western Australia because of weather conditions for Sydney. So it is definitely easier to get to Sydney, but it's going to be. I've lived in Sydney. I lived in Sydney for 10 years. July is not a good month for clear skies. So
and you never know too. In cities, if street lights might come on automatically too when it gets dark through the totality, and that will ruin the whole effect of the total solar eclipse. So hopefully Sydney will, if it is clear and cloud free, hopefully they may manage to make sure their automatic street lights don't come on.
I'm looking, there's 2062 is over Albany in the southwest, and I'm looking forward to 2068. I'll be 84 years old, but it's going to go directly over Perth and the observatory as well. So that's my one. I'm at least hanging out for that one. So yeah.
You've got to go
on your calendar, right?
Yeah, got it marked right there. Okay, so I will go into a little bit of. So Roger's going to get all our objects ready to go. And I will tell you a little bit about the Perth Observatory. So it was started because of this gentleman, Sir John Forrest, who was the first Premier of Western Australia. He was wanting to build an observatory for not only to do astronomical research, but for also to keep time here in Perth, to do weather reports, and also trained surveys and navigators. So the original trig point for Perth was on the Perth Observatory. So we have the foundation stone here, and so you can actually see these little symbols here. So the outer symbols are the zodiacal signs, and then the inner symbols are the planets and where the planets were on the day of the laying of the foundation stone around the sun. This is the original astrographic dome and our very first telescope dome. So it's a Grub Parsons astrographic telescope, and that was because we were part of the Carter-Seal project, which was a massive undertaking to map the entire southern sky to as good as the northern hemisphere. This was our very first government astronomer, Sir William Ernest Cook, and he was brought over with the government astronomer for South Australia called Sir Charles Todd, as he was his assistant, and he was
said to, it's recommended as the first government astronomer of West Australia. And that's the original site of the observatory. This was in West Perth, right near the CBD, and it was, at that time we didn't have very reliable power here in Perth, so you could have your observatory nearby. So the main building is still there. The domes have been demolished. So that we started in 1896. So you've got we had a time signal down to the Fremantle time ball, which Fremantle is the local port here. We developed West Australian Standard Time as well, and we ran all the government clocks and public clocks as well. So William Ernest Cook was doing the weather reports for the from the start until about 1908, when the Bureau of Meteorology was created. So, and they were some of the most incredibly well detailed plans across a much larger area than anywhere else that was being done. We've got the public viewing area so Tuesdays were public viewings and public talks. That telescope there is the Calver telescope. If you do come on a night sky tour with the observatory, you will actually look through that telescope, and that was purchased in 1910 for the comet Halley coming into the inner solar system. So we have about 28,000 glass plates from the Carte de Ciel project. We were given a small part of the night sky that we were to take photos of, and we took that from 1901 to 1919. The project was left incomplete in 1930. We were part of the Wallal expedition to help prove Einstein's theory of general relativity in 1922. And in the middle of the 1960s, the observatory moved from West Perth into Bickley in the Perth Hills, about 45 minutes away. So the very first dome that was built was our Meridian Dome, and then we had the Astrographic Dome was rebuilt. This is, hopefully we don't have any people that work in OHS. You'll notice the number of OHS rulage breakages there that are being broken, and that's the Lowell Telescope Dome that was built here. We were part of NASA's International Planetary Patrol Program from 1970 to 1976 when the project finished, and that was to map, to keep an eye on the planets Venus, Mars, Jupiter and Saturn, because NASA was sending their probes out there, and there were 7 telescopes around the world keeping an eye. That's the Lowell Dome today, and that's the telescope in there. That's the Bowler and Shivers 24-inch telescope. That's the aerial site from 1982, so even before I was born. So you can see the new main building right around here. A lot of this area here has now been cleared, and we've got more domes. That's the very first public dome for Perth Observatory in the new location, and we still use that dome to this day. The really big thing that we claim to fame is that we co-discovered the rings of Uranus's rings. So we made that joke slightly dirtier in the 1970s. And so there was an occultation, and where Uranus was passing in front of a star. We get the co-discovery because we helped. We caught the first part of the rings. Unfortunately, Perth was just too far north for the whole occultation, but we were able to back up the data from NASA's Kuiper Airborne Observatory. With Comet Halley coming back into the inner solar system in 1986, there was a lot of work done there. They had the very first digital camera used in Western Australia was brought out by University of Maryland. They realised that the rotational of the comet was about 20 hours or so. They discovered that there was cyan jets coming off Comet Halley as well, and 10% of all the images that ESA's Giotto spacecraft used to get there came from our Astrographic telescope as well. In the 80s, the night sky tours were restarted. That's photos closer to now than in the 1980s. And in 1996, the Perth Observatory volunteer group was started to help the astronomers run the night sky tours. And this gentleman right here, Bevan, is still part of the volunteer group. So we've still got one from the original OG members. And so, unfortunately, in the early 2010s, the government took the money for research at the observatory and moved it towards the square kilometre rate. But we ended up signing a 10-year commercial lease agreement in 2015 and 16. We had a 1-year agreement, and then we went to the 10-year agreement with the volunteer group running the observatory with the state government department. So some of the stuff that we've done is we've got an art exhibit called War Wonkin, which is Noongar for Star Stories. That's the local indigenous nation here. And so you've got some stories in Noongar culture. We also restarted the off-site events, so West Australia is the second biggest state in the world, so we do get around. I've seen a lot of the part of West Australia, and I'm very thankful for my job here at the observatory so that I can do that. And that photo there was an off-site event at the original observatory's location. We've streamed eclipses, so we started off with time and date for the 2018 January super blue blood moon, and I think we're up to about 7, including the total solar eclipse in 2023. And Roger's actually helped me quite a lot with these. Not the 2 a.m. ones. He knows that it's better to be in bed for those ones, but and away from the cold as well. And we've also brought some research back as well. So we helped out NASA with its Lucy mission, and you can actually see here this star here. It will blink out. So we recorded Patroclus and Monolicious moving in front of that star, and that will Lucy will go and see those two asteroids in 2033. So we've got meteor cameras now at the observatory, so we've helped discover some new meteor showers, and so yeah, it's great to see the observatory back and doing science and also stimulating the public's. We do have knowledge of astronomy. We do night sky tours at the observatory Friday, Saturday, Sunday, except for the full moon weekend, and they are fully booked until June, so they are very popular here.
Okay, I'll just get the webcam
Back. Roger, are you ready to go?
Yeah, sure, man.
Okay, cool.
What would you like me to start with? And apologies to Carol. It seems like Carol popped over. She's from my view of the world. So I thought for everyone, I still hear Carol. Apologies, Carol, if you try to talk to me.
Okay, so the first target we had was Omega Centauri.
Would you like me to talk a little bit?
Oh yes, please talk about Astrophotography Australia as well.
We've got about half an hour left, haven't we, Matt? Yeah, okay. I just wanted to say, unfortunately tonight it's cloudy here as well, which is kind of funny because we've basically had a clear run since October. The roofs at the observatory here have been open every night since October, maybe one when some rain came through. And you can pretty much map the sunrise and sunset time by the roof open and close time changing gradually throughout those, what's it been, 6 months almost of clear skies. And right now, the rain is horizontal and hitting the shed around me. It's 60 kilometres per hour and raining. that is proud and reigning with the astronomy event, and that is tonight is the astronomy event, and tonight because of that, took a couple of shots here to show you what while it might not be clear skies, it's at least spectacular views, and you can see the regions that Carol was talking about in WA, which are fantastic for astronomy, visual and astrophotography. You can see how flat the horizons are and how little visualization there is there. So that's what it was at sunset tonight when Matt rang me and said, "Hey Roger, where are you?" We were out on the field.
That's a beautiful sunset photo, by the way.
Yeah, you can actually see, because of these storm cells that we've got going through today after the long, hot, dry, you can see the virga that rain, which is coming down and not quite touching the ground there, which is being lit up by the sunset colours. It's really quite, quite amazing.
Actually, I'll show you. This is some photos that I took just before New Year
at Roger's place. So it is quite amazing what you can see in the central wheat belt of West Australia. So that there was the Milky Way coming up with the Magellanic Clouds. You've also got Orion. And some more. You can get green glow as well. So it is pretty spectacular out there as well.
It is good, yeah. And I see references in the chat to the temperature -5. I'm actually pretty darn exhausted right now because I was anchoring outside, pouring concrete for weather masks, and anchoring observatories, and anchoring 10 anchors into foundations for foundations for a scope zone for 38 degrees. And that was pretty hard. But anyway, as Matt mentioned, got a live here to do. Matt, you were keen to start on Amazing Story, I think it was. Now, obviously we can't do the live stream tonight. It's quite ironic that neither us or Canada can.
That's clouds for you. They sense an astronomical event and they go, we must ruin this. That's why clouds are our mortal enemy.
Yeah. So this is streaming from my my personal telescope computer out here, and this is what Matt and I used to use during COVID for streaming. And I haven't touched it since, really. But what you're looking at here is just the southern view of my horizon here. So you can see Centaurus up here. We're going to have a look at Centaurus A and Omega Centauri. So we'll start off with Omega Centauri, which is over here. I'll see this, so it's a bit bigger for you to see. My mouse pointer such a little dot. But that's how my horizon looks here. Matt had me recording a bunch of images during the week in cloud, and I haven't had the opportunity to perfect these at all, and I don't normally do live streaming stuff these days. But if we've got Omega Centauri here, so the combination of stuff which I'm using here, it's actually I can show you a bit of a photo of what I've got here. If you imagine this telescope in a distant observatory, is basically what I'm using. So it's a dinosaur 12-inch Meade Schmidt Cassegrain from 2001 on a Paramount ME. Tracks beautifully. Optics, well, it's a 25-year-old telescope, well, designed 35 years ago or more. On the back of it, which is what I'm actually photographing these images with, is not what you should use for this optical tube. But Matt mentioned an occultation earlier, which the observatory recorded, and I tried recording it, but I was clouded out. And for that occultation, I threw a ZWA 1600 camera on the back of this Schmidt Cassegrain to be able to do the occultation, and it was actually 68. And so I have to admit that as wrong as it is for that optical tube, I just spin 2x2 everything, and even that's pretty crummy. But that's what I'm using for these. The guy who runs the observatory has the port telescope. That is kind of how it works. So if I bring up this stuff here, Omega Centauri. So an individual frame, where have we got a light frame? So I take mostly, up to 3-minute exposures when I'm lazy, because that doesn't require any guiding at all. And so this is a raw 3-minute exposure of Omega Centauri. Omega Centauri, Matt, you might like to talk a bit more about the actual Omega Centauri, but Matt, you might like to talk a bit more about the actual object. But in space, it's this great big ball of stars. In space is this globular cluster, and it is and it is around our galaxy, galaxy, quite fun because of that. It's perhaps not as aesthetically pleasing as 47 Tucanae, anyone who won't recall. A lot of us in the Southern Hemisphere tend to prefer it, or maybe it's just because Australians like the underdog, I'm not sure. So that's a single light frame there of Omega Centauri, and so yeah, unfortunately not being a single shot color camera, which is ideal for live streaming. Your LRGB combination, combining your luminous red, green, blue frame, and this was a quick and dirty hack of that data which I had there. You can see a bit of nice colour there. Doesn't look too bad in the core. It's just something which modern CMOS cameras I feel are much better for handling that wide range of brightness. And so yeah, that's what I've landed up there. Matt, do you want to talk about the actual object a little bit?
Yeah, so it's about 16,000 light years away from us. It is
about 16 degrees below the disk of the galaxy. So these globular clusters are really
old. You've got to think of these as like active retirement village for stars. It is about 120 light years across. So you've got 10 million stars tightly packed in that 170 light years across. They're about 12 billion years old. And so they are very old. So these are population 2 stars. And this is the biggest of the 170 that exist above and below the disk of our galaxy. We have both the first and the second biggest in the Southern Hemisphere. They
can only be seen in the Southern Hemisphere. And so
they are very popular to see. There is actually self-migration. So if you get a small little star form in the centre there, it gets kicked out to the outer edges of the cluster. And if you get 2 stars, say, merge to become a blue straggler, or you get a big star form out in the outer side, that falls into the centre as well. We've never really seen any planets in these globular clusters. We think there probably just wasn't enough material there. But if there was one, particularly in the centre of the globular cluster, there is just no nighttime. There's just, at best, twilight conditions, because there is so much
stars in your night sky as well.
Most of the globular clusters we think might have formed from massive big clouds of gas and dust. But with Omega Centauri, we actually think this might be a dwarf galaxy that has been consumed, conquered by the Milky Way, had all the outer gas and dust and stars stripped away, and what's left over is the core. But we have seen some renewal in Omega Centauri as well.
Yeah, it's an amazing object, and it's a fantastic object to see visually through the telescope.
even in suburbia, you can just make
it out with the naked eye. It is a faint, looks like a faint star.
Yeah.
yeah. So it is quite. It is a
Yeah, and then out under dark skies, you can. Dark
Really
skies, it looks like a fuzzy star in the triangle, which we all recognise in the Southern Hemisphere, that you can sort of do star hopping to. So it really is quite bright.
Yeah. The biggest one we've ever seen is actually around Andromeda. It's 250 light years across, and it's got 20 million stars. It's called Miral 2 as well. Roger, did you want to show Centaurus A galaxy?
Sure. Yeah. So Centaurus A, same constellation of the Centaurus A in Centaurus, and it's just off to the side here. So for us, and it's just off to the side here. So we've been doing Southern Hemisphere astronomy for a while. The NGC numbers astronomy for a while. The NGC number 139 are almost 39 anonymous, almost 4755, which is the Joule box, which is the Joule box. There's just really these well-known objects. Centaurus A is called the Hamburger Galaxy. No one has around the world, but I've no idea. It looks really nice. Galaxies are probably my favourite object, if I choose one. So let's see what I've got here now. I did some shots this week.
We did get a question in the chat. We noticed when you guys were talking about planets not being found in the globulars, and the question was, what was it? What about planet Druidia with dark helmet?
Ooh.
Do you know anything about that?
No.
I don't. I'm not an astrophysicist. I'm an astrophotographer. I'm an astrophotographer.
I imagine there is an Thor's helmet that would not globular in a globular surface.
It's a Space Rules reference. Yeah.
Right. I should have clicked.
Yeah. Actually, they in Survivor's Quest, Star Wars Survivor's Quest, they do actually have a planet, or the Chiss have a planet in the centre of a globular cluster where that's their last stand if they ever get invaded. So yeah.
Matt, you're not trying to bring
There are
sci-fi
names
into it,
for
are you?
exoplanets, so something might easily have been named Druidia at this point.
Sorry, Roger. I know it's a live stream. I've got to try and enter some sci-fi in there as well.
You really don't. You really don't.
Hildy Goldtooth review says, is the Pleiades visible in Perth?
Yes, it is. And it is visible. It's a summer object for us.
So we've kind of given up on it. It's one that we don't usually show with telescopes unless it's maybe like an ED80 telescope, which is a wide field. It's usually one that will bring the binoculars out and see. So, and for anyone driving a Subaru, if you don't know your badge, go out and have a look. It's actually 6 stars, and the Pleiades are called Subaru in Japan. Ooh, lovely. That is.
All right, so back to the hamburger. So this is a single light range at 2 minutes. The same dodgy setup of way oversampled the WO and my Schmidt, but you can see how clearly it comes out in 2 minutes, and the massive glow from the galaxy. Quite obvious visually. In telescopes, there's bar through the galaxy. So I remember regularly out in the wheat belt with visual telescopes, sort of getting a distinct impression of this 2 hemispheres. You'd sort of make out the spherical shape of the 2 hemispheres and the dark lane through the middle, the dust lane through there. And I guess for the purpose of explaining sort of the people who don't know, you've got an awful lot of light coming from a lot of different, all the stars and different light sources inside the galaxy there, and that dark we're seeing is just interstellar material which is inert, blocking the light path of what's behind it. So it's this big dust lane across the galaxy which is blocking the light there.
It is incredibly loud in radio.
So if you have a look, go for a Google search and put in
The gleam image, square kilometre array, you'll notice that there is the bar in radio data for the Milky Way, and then you'll see this really bright radio data object, and that is the that is the Centaurus A galaxy. It actually outshines our own galaxy in the radio spectrum, even though it's about 11 to 13 million kilometres away from us.
Yeah, man, I just saw that I haven't actually done a stack of these, so I've just pulled into Fix Insight here the 4 frames of LRGB, and I was just whack these into another LRGB combine, and we can see almost like live streaming.
Yeah.
Almost like live streaming what we get. So let's just see. I'll just
It is actually part of the Virgo
supercluster as well, and it's specifically at the centre of a subgroup
called the Centaurus A M83 group of galaxies. So M83 is the southern Pillar galaxy, and it is the actual name where the French electronic band M83 got their name from. It is going through a starburst phase, so you'll notice in those photos, and when it eventually comes up, that the arm that we see is distorted, so there has been a collision. And the reason we see these jets when you have a look at the radio data and X-ray data is that that black hole is feeding on dust and gas that is being pushed into it, and they're very messy eaters. And so a lot of that dust and gas is being transported to the north and south poles and then shot out at near light speed and jets
that are as big as the galaxy itself
as well. So there's about 100 star-forming regions that we can see at this, and there has been some considerable debate in terms of literature regarding the actual galaxy's fundamental properties, such as its Hubble type. Is it an elliptical galaxy, or is it a giant elliptical galaxy as well? So it is, I think it's about 60,000 light years across. So it's about just over half the size of our galaxy.
Well, I've got some funky effects going on with the colours here.
Did the blue filter drop out again, Roger?
Not again. No, Matt's referring to when the blue filter unthreaded itself within my filter and went ding inside. No. What's going on this time is this galaxy needed a little bit of wine. Which galaxy needed a little bit of wine? You'd love because Matt always refers to in our the drinking wine at the time constellation name and had no bearing on of course how wacky some of them are. But in this case, what you can see top right, there's some artifact there, but basically all over the image there's actually fogging. When I was doing this week, I discovered that my ZWO camera had got some moisture in it and needed to be given a little bit of wine saver, which is a tip I got from someone, one of my customers actually, is to get a bottle of wine saver, which is basically, it's argon gas. So you can get this $35 off the internet, a bottle of argon gas with a little hose. You can plug a hole in your camera, and you poke the tube in, you flood it with wine saver argon gas, and pop your own. So I did that today, and I had a chance to take photos. So that's why this is way off colours. But anyway. That is the I'm going to crop out that awful rainbow down the bottom there. That is the Centaurus A galaxy, which is beautiful to look at and photograph. You don't see so much colour in galaxies. It takes a lot more data to get that.
Yeah. And you actually do get to see this. It's very faint. With galaxies, it's always best to look off center and use your visual vision to really draw out the light from the galaxy. But you can see the faint light from the halo, and you can definitely see the dark bar, which gives it that hamburger feel as well. Okay, so Roger, did you want to move to the Carina Nebula? I can show them where this is.
Yeah, I can do.
Yeah, I'll show them while you're setting up in Stellarium.
We're excited for this one. We're excited for this one.
I'm going to disappoint you a little bit because I don't have any recent images from the kit. But I'll pull something up.
So in the Southern Hemisphere we have, actually, and this is the skin for Stellarium for the observatory. It's just slightly old. You do have the Lowell telescope here. We do have our Jubilee dome, which has our 30-inch telescope in there. There's the original public viewing dome for Perth Observatory here in Bickley. So we have, right here, we've got the Southern Cross. We're just going up slightly higher. And there it is right there. Lovely, lovely nebula right here. Okay, I'll go back to the live stream.
Yeah, got a question in the chat about argon gas. So we use argon to the CMOS chamber, or almost say CCD chamber, because it's embedded in our brains as CCD. But yeah, we use argon gas to fill the chamber and push out any moisture, so that when the cameras are cooling, they don't get condensation inside the CMOS chamber. Matt, apparently there's some echo going on. Also.
Yeah, I think it might be the storm's effects on the fixed wireless for you. It comes and goes, so.
Okay, probably more likely my AirPods. Yeah, sorry for everyone who's.
It does. It only goes for a short period of time.
Okay. So we've got Carina here. Carina Nebula for us is part of the Southern Milky Way, and Southern Milky Way, and I shot probably a wide field shot. My night is more my recent work. So it's very high in the sky at the moment up here. You typically look for it on the opposite side of the Southern Cross to the pointers. So you have Alpha and Beta Centauri, and then the Southern Cross, and then Eta Carina. So it's this. What have we got here? This shot here. Just taken with a little Fuji XE2 off-the-shelf camera, and this one here was taken with a Canon DSLR. And those were both through small refractors. So one of them was through an 80mm and the other one through a 90mm, but within optics. But yeah, nice wide object, so fairly wide field of view that you've got there. I forget the exact degrees, but several moon widths. So that's it. Big. Now, I did try a few shots of one, but I was having a nightmare of a time.
Did you say that thing with several widths in diameter?
Yeah, that's right.
That's really big. It's really big.
Yeah.
It is.
It's roughly about.
It's like
It's roughly about 8,500 light years away from us, but it is one of the biggest nebulas. It's about 230 light years across. And it is very prominent. Even at the observatory, you can clearly see it in the night sky above this Southern Cross.
There we go. Here was one which I was working on earlier from the data. It looks terrific. Apologies to all people out here in Southern Hemisphere. They're much better, but I was just taking shots. And had a chance to process them. And my focus.
That's the homunculus nebula right there.
Yeah, well, that's right. Yeah, well, that's right. Actually, someone who's in the Astrosphere was did a fantastic job of that nebula. I decided to use two images of it. Where is it? Oakley Chapman in WA did a fantastic job of photographing the homunculus nebula around Eta Carinae star. I don't have it here because I've just got an overexposed star. I just did one set of images which were 120 second and 60 seconds, which is what I was expecting to use for the live stream. But the thing which we like about Eta Carinae, so I guess to give people reference, what we're looking at here is a tiny little subset of a little crop in of what I showed you originally. That probably wasn't obvious. So if I go back to one of these guys here and just pull up this image, put it up. So what we're looking at here is sort of a little crop of this keyhole nebula and Eta Carinae sort of part in the middle here. So my main telescope there, which I've been using, is the Schmin, which has a 2000mm focal length versus the earlier shots, which are around the 500mm focal length. So we've got Eta Carinae the star, which if you could correctly expose that in the photo, you'd get the beautiful homunculus clouds that you see in the Hubble shot, and from people from shots where you sort of do really short exposures to get that. But then we've got the beautiful dust lanes of the broader nebula. We really like this at the observatory for Tones people because you have so many going on here. You've got Eta Carinae star, which Eta Carinae varies in bright massively throughout time and you can chart that yourself quite easily varying week, month. You can see the brightness of the star go up and down. Doing a line over that. Then you've got the broader nebula, which is a real mix of star forming, reflection nebula, and emission nebula. So we've got everything in there. And so we really like to use that as a story. And you've obviously got dark nebulas as well, because you've got this interstellar dust here, which is this obscuring background information. So yeah, that's Eta Carinae, and again, apologies for the quality of the images there.
It did become the second brightest star between March the 11th and 14th in 1843. And then well below naked eye visibility after 1853. So that homunculus nebula is this massive nova event that happens that made it as bright as Rigel in 1843. So it was discovered by Nicholas de la Caille in 1752. It does have a number of star clusters within it, Trumpula 14 and Trumpula 16, and there are some massive hyper-giant stars in Trumpula 16 as well. So it is a very nice one to show.
We usually always show this on our night sky tours as well. And so you've got to think of nebulas as stellar nurseries. You know, this is where baby stars are forming from dust and gas being rammed together, and then producing stars over millions of years. Once that dust and gas gets forced into the protostar, and that protostar getting bigger and bigger and bigger and bigger, and as it's getting bigger and bigger and bigger, the pressure and also the heat forces the atoms to then, hydrogen atoms, to become helium, and the star basically turns on from there. So you'll notice all these little nodules there, they'll produce these things called Bok globules, and they will be little cocoons where baby stars are forming. So there's thousands of stars in there.
All right. Maybe the last object is the meat hook, which we should
just
do,
one more.
Matt. It's got a bit of
This is our new favourite, isn't it, Roger?
Well, it's been my favourite. One of my favourite galaxy years since the days I view it out in the week visually. And I want to show this one because for us guys who started visual stuff 30 years ago and so on, the meat hook has always been there. It's a nice bright galaxy, fairly discrete, sort of defined. In the constellation of Bolin, so it's a very southern object, and it just has beautiful structure to it. And I love galaxies, but also love galaxies which have some sort of interaction. And this one has all of that. And I actually learned a bit more about it today. So this is just a single exposure. I did not get around to doing a stack of these images tonight. So I'll just show you this one. Time's dragging on a bit, but it's interesting that the detail you get just a single exposure here and how beautiful it is. You also have this galaxy which is just barely on the frame down the bottom, and that galaxy is actually the PGC galaxy. I'll get the PGC 21457. That's the catalogue number, which is actually it has interacted with this meat hook galaxy about 250 million years ago, and so that's why the meat hook has the distorted shape that it has. I love to see that kind of thing in action, and it's actually interesting that it was when I'll read this a little bit out, when John Lewis compiled the NGC catalogue, this was identified as being two separate nebulas, and so it's actually got two catalogue numbers, NGC 2443 and 2442, but they refer to the same object as we now understand it. It's fascinating that I didn't realise is there was actually a supernova discovered inside this southern galaxy by the Perth Observatory, by S. Woodling, Ralph Martin, Andrew Williams at the Perth Observatory. And that was in 1999, April 30. So it's about 15 years before us volunteers took over day-to-day operation of the observatory. It's designated SN 1999GA, and so that's the telescope which Matt showed earlier at the Perth Observatory, the Perth Lowell Observatory telescope, that discovered that supernova. So there you go.
And Andrew actually works on the square kilometre array, and Ralph actually ended up being the last government astronomer of Western Australia as well.
Yeah.
Acting government astronomer, yeah.
Yeah, so I think that's the meat hook is fantastic galaxy. There's a whole bunch of fantastic southern constellations for galaxies. Fornax is, I guess, a little bit more north, so probably visible from much of the northern hemisphere. But yeah, Fornax has fantastic wide selection of galaxies there.
John had just mentioned before with the Carina. Yes, it's one of those stars that we like to say about to blow up, but astronomically speaking, it could have already blown up and we're waiting for the light to get here, or it could blow up today and tomorrow and then we're waiting for about 8,000 years, or it could blow up 100,000 years. So it's one of those things that it won't happen overnight, but it will happen. So go on.
Yeah, all right. Oh, no, that was it, Matt.
Awesome. All right. Well, thank you very much for everyone who stayed for the whole time. It's been great being able to show you these objects, even if the cloud and snow tried to ruin us. No, we were able to do it. And so...
It feels like I'm about to get blown off the planet. the doors are rattling and the wind is howling and.
You might actually be in the safest part of that observatory, so just stay there, Roger.
Yeah, just hunker down.
Yeah.
We also, just real quickly, want to apologize for the echoing and the reverb that some of the listeners might have been hearing. Probably not a whole lot we could do about that. Hopefully, when this gets re-uploaded, it'll sound a little bit better, but we'll see.
No, but look, it's amazing that we can actually do this nowadays, because I can remember 2012, there was a total solar eclipse that went across the centre of Australia, and they ended up, someone from the telecommunication here accidentally cut the link between Alice Springs and Adelaide in South Australia, and no one could see the eclipse unless you were actually in the path. So definitely, I'm looking at how many drop frame rates here, and it's unbelievable that I can do this now from my home. Like back in a couple of years ago, I wouldn't even dare try to run this stream from my home. So we were running it off a 4G router on top of the Lowell telescope dome at the observatory. So yeah, it's fantastic. And thank you very much, Carol, for putting us in touch with Perry and Brady. And Brady, and we'll do this. Sorry, just a little saliva in the back of the throat. But we'll definitely be doing this again as well.
I think so, yes.
Yeah.
It's a lot of fun.
Really fun.
There's plenty of objects in both the hemisphere and the southern hemisphere as well to go. So thank you very much, guys, for coming along and having a listen. And if you're in Lethbridge or in Perth, definitely come and see us at the Perth Observatory, and also the guys at the Lethbridge Astronomical Society. And
You're
also
always welcome to bring your weather with you if you're coming for a visit.
the 38 degrees, yeah.
Yeah, whatever your weather is, we probably want it, and vice versa.
And also, it is definitely worth getting out and looking at Astrotourism WA website. They have a map where you can go and have a look at all the the nice astrophotography locations and astronomically looking areas in the wheat belt and in the north and around West Australia. It's definitely worth going and having a look if you're coming to Western Australia. And keep an eye on the Astrotourism WA website for Carol's events, and also Stargazers Club WA as well. Thank you very much, guys.
You can also find us at Lethbridge Astronomy Society.ca.
Yep.
And for people that are interested in dark sky preserves in Canada, there are 5 in Alberta. Most of them are up in the Edmonton area, but there is one called Cypress Hills that is a little bit closer to where we live. It's about 2 hours away. And then we have a national park called Waterton, which is another very good place for dark skies.
And you're on Facebook? Do you have Instagram or Twitter?
We do have a public Facebook page, also weirdly enough called Lethbridge Astronomy Society.
Awesome.
It's probably not as updated as we should have it, but it does exist as well.
You can go to perthobservatory.com.au, and we're also on Facebook, Instagram and Twitter. Roger, where can people find you on the internet?
Look, astrophotography.com.au and astroobservatory.wa.com.au, but yeah, that's where you'll find me, or at the Perth Observatory.
Yeah. Roger does our astrophotography workshops, and he also does his own as well, and he does them for Carol as well. So yeah, so we're a very tight community here in WA. All right, guys. So thanks again, and no worries. Thanks. And we're definitely doing this again, so probably around this time next year as well. See you guys.